All right, we are recording. So we're going over the 8th chapter of Refactoring by Martin Fowler. This is all about moving features and moving stuff around. By far one of my favorite refactorings of all time is in this chapter. So we'll talk about that later. But who wants to kick it off tonight? Don't make me do it.
It's the nerves. It's the nerves. It's like, should we call on people? Who hasn't gone first yet? I don't want to pick on anybody.
I mean, I could start us off again. I don't mind.
Go for it.
Yeah, all right.
My standout refactoring from this chapter was the next to last one, I think replace with pipeline. Nice. And the reason I liked that one was I like how he did things like really step by step, because he kept the original loop and then started slowly introducing that pipeline. And I thought at any point you can walk away and it'd still work, which was great. And I'm glad he took the extra time on that one to show people kind of how you go about doing it, what the benefit is,
Yep.
So definitely like that one. I would say in my experience, most people just kind of start from scratch and just kind of look at one and the other and kind of just try to replicate it. I like how you can do it step by step, especially if you have tests. And the tests kind of show you that things still work. So that was me. The other ones to me weren't as exciting, I guess. Especially the last one, like remove that code. It's like, yeah, okay. But this one I thought was the most valuable one, where if you've never done pipelines before, it might show you the kind of the benefit, the power of using them versus traditional loops. So I like that one a lot.
One of my favorite conference presentations of all time, and I'm just going to give him a shout out in this call today, is Rethinking Loops by John Carey from the Kansas City PHP user group. Mm-hmm. Amazing talk. It's all about replacing for loops with pipelines in PHP. And I carry that with me everywhere I go. And so when I saw this in this book, I was like, oh yes, that's me right here, because I'm constantly trying to encourage people to kind of think that way. Because there's nothing wrong with a for each loop, but anytime I see like that for each if, I'm like, yep, you wanted a filter right there. You're trying to get one thing out of another thing, and let's just be explicit about that, versus like, having this nested structure here that we're trying to work with. And it's a mixed bag, to kind of, you have to kind of do it and see it a lot to be exposed to it enough to be able to understand how it works. But I think once you start to recognize it a bit more, it becomes almost second nature, like, oh, I want to do that now. So it's almost like this next level refactoring, because you also need it's like almost a functional programming paradigm versus other routes, right? So, well, pardon me,
I'm so glad y'all led with this one. Jeremy and I, right before everyone else joined, we were talking and we were like, this is what we picked out, because after being exposed to it, and I will also point out, Jeremy Ward, well done on the John Carey, and you said you carry his talk with you all the time, and I was like, I like it very well. Well done. But anyway, so yeah, we were talking about how, after I started being exposed to this and getting into the taste for pipelines and how they actually really help, I was like, now I don't think in that iterative flow anymore. Like, I don't think in terms of iterations. I now think in terms of collections and filtering and doing all, like, mapping and all kinds of stuff to transform into what I actually want to do. And so it's almost like anytime I'm reading code, I'm like, oh, what is this for loop? What should it actually be? Like, it's like, I think it's wrong. Anytime I see a for loop, I'm like, why are we doing this? Like, this seems like a bad idea. So yeah, I'm glad you brought this up, because it's one of my favorites out of this chapter as well. So
yeah, I'm a huge fan of this as well. I mean, well, Jeff, as we were talking about just before everyone else came on, but I mean, I remember when Java 8 came out and introduced, Java native support for collections as well, and starting to use this stuff. And I mean, I think for me, the biggest thing was knowing that I can just write what I want to happen without having to describe how it happens. Like with a for loop, I'm saying, assign this to a temporary variable, and then if this condition is true here, do this other thing, and so much and so on. Like, but the ability just to be able to say, do these things. I personally feel it, for me, it reads so much clearer. I have, colleagues who disagree with that, but that's why we have interesting conversations at work. So
I worked in Ruby for a while, and it's like enumerable is a huge, just like anything that you want to do in Ruby apps is, I'm always like, what can I find in enumeral that will actually do this for me? And then when I started working back in PHP, and then like Laravel, now I find myself reaching for Laravel's. They have a wrapper around, like you could pass like an array, so it's very common to have arrays in PHP apps or libraries, so that you got, and you could just pretty easily wrap those, and then you have access to all these methods on collections that you don't have on arrays. And it's like, the jokes about having 50 different method or 50 different functions in PHP to do like a simple array filter or whatever. Like there's 50 different ways you can do it, and now it's like, yeah, but you don't have to think about that anymore. Like I rarely go pull up that page in the PHP manual that's all the array functions. I'm like, okay, which one did I want today, or which of these 50,000 character long iterators do I want to use? I want to use a recursive iterator with magic or whatever, and but I no longer do that anymore. So it's like it's great. Like I really love the code. Like it's a lot easier, like you're saying, Jeremy, like understanding what the heck is going on in the code when you're, because it reads in terms of, I think what you were saying, like it reads in terms of what am I trying to do, not like how am I trying to do it. And that's the difference, is it's easier to read the what or the intent behind it, to me, in pipeline form. And so
yeah, well, another thing that I liked about John Kerry's talk and how it applies to this book too, and this particular section, that Fowler doesn't state specifically, but it's this idea of reducing nesting too, because a for each if loop, automatically now you're looking 2 levels deep to figure out the thing that you're trying to do, versus just reading your code in a straight line. And when you're suddenly using a pipeline, that's what you're doing. You're like, I have this set and I'm trying to break it down to this set, and maybe I'm converting it to something else to get my result.
Yep.
And so I really like the way that he went through the step by step. And to echo what Bernard said, was like, I still haven't captured this fully in my mind from the book, but the way he does it, where he's like, each step of that change, it always works. Like that's I think through practice you like start to master that. But I think for me, it's just even like seeing it and then knowing that I can get from point A to point B and kind of get to that result eventually before I commit something. Oh yeah, at the last point, then I check that it still works. I need practice for the rest of it, but it's great to see it like in practice with those extra different steps.
Yeah, that technique that he used was kind of cool, like where he basically like built the pipeline on top of what he was on top of the loop, and so he's able to use that to feed the bottom. So you're basically doing effectively what the pipeline is doing, just breaking out line by line. So yeah, I think that's really cool. I can't say that I've ever done that personally, or like even thought about it, or whatever. I mean, maybe I was telling Jeremy also earlier, like this week I 2 times caught myself doing a inlining of a method. And before I was like, I never do this. Like I never do it. And then I did it twice in 1 week, and I was like, maybe I do this. And I just never thought that I was doing it, because it didn't really stand out. It didn't have a name or whatever. So yeah, I think his methodical approach here was really cool. And just like that idea of, because I feel like if I was doing it, I would have looked at it and been like, okay, let me just replicate this and then build the pipeline that I want based on what I'm seeing, like separately. I wouldn't have ever fed the pipeline code into the actual original loop, so I guess that's a cool technique I should try, maybe.
Yeah, it felt very
maybe related to this.
Yeah, sorry, Jeremy. I think in the previous chapter there was the replace algorithm for refactoring. It felt very similar to that, although I think with that one he didn't really use an example. It's just just replace the body of a function or something. This one, it felt like, here's how you actually replace something. Like you start off with something that works, and now you're slowly replacing with a more optimal solution. So I really like that too, and I kind of wish he delved more previously with the replace algorithm and said, like, this is what I mean by replace. Like, just don't erase it and start over. Like, do it step by step like this.
Almost like that chapter, which was very short, should have had a little stay tuned for more mention in it.
Is the duplication then the key, I wonder? Because, I was going to mention the split loop refactoring, which maybe we'll come on to in a minute. But the thing he did there was begin by just duplicating the code. And he talks about how if the loops have, a free of side effects, then that's enough on its own. But he had to do a little bit more in his example before he could run that code and get it to pass. I wonder if that's part of it. If you can, I mean, certainly, there's a wonderful refactoring that's not in this book that Llewellyn and Falco does, and it's very, very specific. Like if you have a whole bunch of messed up logic with conditionals all over the place, it's called lift up conditional, and it's a way of grouping together all statements that that relate to certain code together. But it's all done entirely through duplication. And then you basically run your test and you run it with code coverage and you look for dead code and you delete those lines and both branches of the loop and you keep going. So it's I wonder if there's something there about changing algorithms as well. Like if you can duplicate something and send code down one of either paths on different occasions, that I don't know. Maybe I need to think that through a little more.
Yeah, I think that just the duplicate and have multiple paths to execute, I think is kind of a common in a lot of these refactorings. It's a common technique for getting there or getting the first step done anyway. So yeah, I mean, I think I see your point. So probably is part of the method to the madness.
Yeah, I'll see if I'll try and work out what I'm trying to say by next week.
Yeah.
I think with this one though, he didn't really duplicate. He was kind of replacing one slowly with the other.
Yeah.
So I saw him do the duplication in some of the other refactorings, even in this chapter. But with this one, that's why I liked it so much, because he's slowly kind of swapping one, like weaving it into the other. One feeds into the other. It was great because I've never really done something like that before myself, especially in this kind of specific scenario with collections. So that's why I really liked it. And I think in other cases, duplication might make it simpler, especially in some of the ones where he, creates a new function, slightly different name. He starts off with the exact same copy of the body, then he starts doing it. This one was a little bit different to that. That's why I like it so much.
I'm definitely going to try next time I am destroying a for loop or whatever. I'm going to try to see like if this, because it works well for the example in the book. I'm just curious like how, or if I even am able to do it. Like generally I think when I do this, like if I'm trying to think about how I would approach it, like I typically look at the loop and then look at the inputs, look at the outputs, and then kind of guess on like what is the first, kind of think of it like how you'd execute like a query, like a SQL query or something. Like what's the thing that I use to get the smallest set of data that I need to work with and just build the pipeline that way versus I think what I'd have to do to make that that progression work, I'd have to like look at, okay, I know what the starting point is. So I know my first collection would be the whole group. And then what line in there corresponds to a filter, which one corresponds to mapping, or so I'd have to like look at how are we transforming pieces and then get it right every time, or like get the order right, because otherwise you're gonna end up in a weird spot. So I think I'm gonna try it. Like I think it's cool. It looks cool. I'm curious if I can actually do it, without reverting to my previous methods of what's the output I'm trying to get, and then how would I write this?
The beautiful thing about that refactoring as well, though, is because it's so incremental, and assuming you have a great test coverage, you can just run a test after every change, and as soon as the test fails, it's
Sure,
like,
yeah.
back out the last step is obviously something like, the great thing about it, the test fails, it's telling you there's something you've misunderstood or something you haven't understood yet.
Yep.
Yeah, let us know how it goes. I'm sure you'll be, I don't think it will be a problem. I'm sure you'll be able to do it.
You have high confidence. I'm like, I don't know.
This book maybe needs some worksheets, some problems to work through afterwards. So like, here's an example. Now go refactor this, and here's the test to go with it.
There is a companion book to the old edition that's kind of like that. There's like a working book but it's all like the first edition, like Java examples, and then they expand it more. I've been looking at like, could I adapt code that I'm actually writing for, work or real things two examples that I could use to kind of work through stuff, because that's always a challenge. And then the other challenge is, how much time can I reasonably spend, playing with refactorings versus, actually doing what I'm supposed to be doing. So it's a game.
Well, along those lines, so I was talking about, mentioned split loop before. Someone's taken the example from chapter 1 and made it into a code kata and put starting points in 10 different languages. There's everything from PHP to JavaScript to Kotlin to Java, the whole lot. But the big thing about that code is there's a giant for loop in it. And in Prince, do you remember there's a statement printed that prints the theatrical players' invoices, and there's a giant for loop where everything happens.
Yep.
So it's a great example for for the two refactorings at the end of this chapter, the penultimate and the one before that, I think it was, which is the pipeline and the split loop, because kind of split loop leads on to replace loop with pipeline in some respects. Like he talks about how split loop is a precursor for other refactorings. But that kind of comes, the one for me that when I first read this book and still reading it again now was really quite revelatory in this chapter was the split loop one. And simply because I never really thought before about how much, like we talk about switch statements being, or if else statements being a place where junk accumulates, like object-oriented abusers, I think people call them. But it's a similar thing. I never thought about it that way with for loops. We see a loop and we're like, well, I've got to do something else. I'll just put it here. We're already iterating. I'm just going to put this extra thing here. And then it just grows and grows and grows. So I found it really refreshing. Again, the first time I read this and reading it again is like, the cost is probably going to be negligible. And the benefit in terms of legibility and the opportunities to restructure your code. And he's like, if do the thing that makes the code readable first, and then if you do find there's a performance problem, then it's very easy to optimize afterwards.
Yep.
I think everyone I speak to. Go ahead, sorry.
Yeah, so I liked in there that, I was reading the split loop one, and I got to the point where he said, a lot of programmers are uncomfortable with this. And I was like, oh, I feel very seen. Because it's like, I was just thinking the whole time when I was reading the introductory, words, I was like, oh, we're talking about duplicating a loop twice to iterate over something. But I did like the general setup and like the whole, you're doing or populating two different things in a loop and you're already in there going through it. But I like that he got through with the whole thing and said, here's how you could do it. Here's how you could split it up. And then also, actually, now that I've taken it down to this bare kind of showing you, hey, I'm doing these two things, I'm calculating these two values, I could actually replace all the work that was being done there with it was a map or a reduce or whatever it was. Like, so he was showing like, once you get to the point where now instead of having to think in terms of I'm iterating and I've gone through this and I'm plucking this value out and putting it here and then populating these two different variables with things and returning those in a data structure, now you're looking at it and saying, this loop is actually just calculating a sum, and this loop is actually just doing this. Let me just do that work instead, using libraries that are already built to do that, or methods that I've already written that do that somewhere else. So I think that was kind of the power of it to me was, get over the entrenched thought of, I can't iterate over these arrays twice, or I can't iterate over these collections twice, and just think of it as I'm boiling this down into something that is understandable from a problem perspective, and then I can turn that into either something that is useful outside of this context, or use something that's already written that does this better than I could write it in my iterative code anyway. So that was the power of that one for me, was getting to that last like couple lines of
no
That's more God loops.
Yeah. What's another example of that refactoring is you have an insight in your mind, you transfer to the code, which generates a further insight. Like you never would have seen those things, the place where you got to with that code, if you hadn't done the initial split loop.
Yep.
And
also the naming, right? Like,
yeah.
It's also the naming, right? Like because once he got to the end, I think, didn't he? Let me try to find it, but I think he renamed the variables, or he moved them together or something. I don't remember what he did, but he did something and then put them into methods, and it was very obvious at that point, I'm asking for a sum or something. So it was very, very obvious. And it's through that process of refactoring, like you're saying, like it's through the process of getting there that you now understand things that you would have never been able to pick out of that, because I mean, in the chapter it was like 5 lines of a for loop, but in reality it's, you know, it's 30 or 40, right, every time. So you'd never be able to pick out those little bitty pieces.
Yeah. I find this one very hard to convince. Well, I haven't been successful so far in convincing colleagues of this in conversations. You know, I find that people are unable to get past the, you're going to iterate this twice though, that's not good.
Yeah.
So
I can see that. And it's probably just a, you know, you have to explore it to the end of the road before you can understand that it was worth the trip, right? Like you have to get to the point. And I guess you're going to end up with probably a lot of fruitless trips. Like you're going to end up in that, what you just said, I don't know if it was that particular refactoring, but he was like, you know, maybe you get to the end of doing this and you decide, oh, that was not a good idea. It's very easy to undo it. Like you can always just go back to having one big loop. Like that's not, no one's going to be upset in the performance issues. Like no one will, you're not losing anything by trying it. And then maybe but maybe you will gain something. So probably worth the exploration.
Well, and like with anything else too, he's not saying always do this. He's saying there are scenarios in your code base where this will crop up. And this example lends well to itself because what is being calculated is actually 2 different things. And so it makes sense for them to have 2 different methods, which if they were just 2 separate function calls, which they ultimately become, they would have their own loops anyway. And so, you know, we do a lot of, we don't do everything in a single loop. If we use loops, we use them all over the place. And this kind of just drives that home, like, yeah, the performance doesn't really matter because you're probably looping on something else somewhere down here when this code gets executed. It's just, this makes it more explicit and there are no performance considerations and you are calculating 2 different things. But there may be a case where you need to loop over something and you are adjusting a couple of things within that loop because they're all related to the same singular thing.
Yep. It's also funny, like you know, you always have to remember, like you're thinking in terms of, or at least, you know, I'm thinking in terms of what's a large number of things to iterate for me, you know, more than 10. And I'm like, I don't want to do this anymore. Like if you're like step by step writing it out, but like a computer doesn't care. Like it's like iterating over 100,000 is not really an issue most of the time. So it's like one of those things where it's like, you've got this preconceived notion based on your understanding of the world. I'm saying your, but like, you know, as a programmer, like you're thinking like, oh, if I had to trace this particular loop 10 times, I would be exhausted. I wouldn't want to do it. But, you know, you're doing it twice is not a big deal from, you know, 10 to 1,000 or whatever. Like, who cares? Like, no one is, the computer doesn't bat an eye at that. Doesn't have an eye, but, you know, you get what I'm saying, right?
I think as well, we get so hung up on these things as well, but we tend to forget, at least I think in all the languages that all of us here are working in, that we're so far removed from what's actually getting executed.
Yeah. That,
you know, by the time the compiler or the interpreter is done, who knows what's actually being executed. So really at the level we're kind of, most of us I think are working, or all of us are working on the call, the legibility is the thing, right? It's making it understandable is, people used to say in Java, you know, that string buffers were, I think it was string buffers marginally faster than string concatenation. It's just like, you know, microsecond faster.
yeah.
And it's just, it was a perfect example of micro optimization, which is just like, just do the most readable thing. No one's going to notice at that level for you know, in 999,000 times out of a million.
We need to seriously have a conversation about single quotes versus double quotes and like interpolated strings and non-interpolated strings. And you have no idea how many, you know, cycles you're going to save yourself by not giving it a double quote. It's just like, seriously, like, no, like it's not a big deal. Yeah.
But I kind of blame computer science theory on this one. I remember taking, you know, complexity or big O notation, and if you were to put that answer on an exam where it's like, I'm going to do a split loop, you probably get the wrong answer because it's like, it's not the most optimal. Or if your search or, you know, sorting algorithm did something that's like, well, it's not the fastest sorting algorithm, right? So I think that's the problem. That's my biggest gripe with computer science theory in general, is it doesn't actually tell you in reality what would actually make sense to you when you're actually, doing this. Sure, you might not have the most optimal solution, according to, what the computer could process, but you as a human being, reading this, it's probably not as optimal doing it that way as Martin Fowler is trying to show here. So I can see why certain people would be against this. I mean, I probably would have 10 years ago said the same thing, but seeing this more often and seeing that, yeah, it doesn't really matter. Computers are so powerful these days, like it's so negligible, but yet in theory it would be, not the most optimal answer. And so some people will still kind of fall back on that. So I kind of blame people getting college or university degrees on this one.
Yeah, there's that, but there's also like, imagine you're, writing for, like a website or something where, hey, you have compute problems, just throw more servers at it. It's not a big deal versus like writing a embedded app that's on like, phones, like older phones, especially, or, you're sending a satellite into space and, it's only got so much that it could do. There's only a finite. So I get like the computer science thing, like, as much as I'll join you in your, a lot of stuff that you do, especially in those intro to algorithms classes, is like, yeah, this is great. Like, I get it, but I'm never gonna like, I calculated the big O of your function and it's 2 log n. So I'm sorry, you're gonna have to rewrite it. Like, I would never get into that with what I do. But like, yeah, I mean, I could see both sides of that in particular, but this, for most, like what Jeremy was saying, like most of the stuff that we're doing, much smarter people, and they've had a lot more time to think about, have optimized compilers to the point where you could write something really dumb and they can fix it. Like the compiler could fix it magically. And like, that's, when you get into like database optimizations of queries and stuff, and people are like, oh, I ran explain on this MySQL instance and it's got this index. And you're like, yeah, well, that's not how it works in reality. Cause there's caching involved. There's a whole bunch of stuff that this all gets like optimized to something that isn't even remotely what you wrote. And like, there's no, without digging into it for weeks, like you'll never really understand what the optimizer is really doing. So like, it's negligible to consider that as your first, I guess, like, don't consider that as your first line of, thinking, like how many loops did you use? It's more of, do I understand what the heck is going on? And that's kind of what we're going for with this book, I think. So
It's the same reason we like use words for variables and don't just use like A, B, etc. Right? Right. Like if you're optimizing for how many for loops you have, you should also be optimizing for your variable name length and how many comments you have in your code. All of that compiles down and it increases the size of your app.
And don't forget to optimize the size of your database columns, or every byte counts. So like if it's maximum characters, don't use variable character types of any sort. Yeah, we just got to make it super tight on that memory and compute management. Or you get the code that's like in languages where it's like forcing garbage collection, or like going through and like, I'm going to manually manage memory in this thing. It's like, yeah, well, I mean, this isn't C. Like, we don't have to do that anymore. Like, that's, yeah.
We should all review code this week and put Jeff's comment in. It's like, I've calculated the big O of this function and it's 2 log n, and it's got to be redone, and just see how that goes.
Yeah.
So it's maybe not the, I don't know, the most amazing refactoring in the chapter, but it's one I use all the time. Slide statements. I was like, yep, you're speaking my language here, because let's just put things next to each other where they belong, next to each other. And I love it because it does set the framework for like, hey, you're going to do this, even if you don't do this because you're going to do any other refactoring, it helps you understand it a little bit better, how things are structured. What belongs together, what does eventually like kind of get calculated when you run any given function. And I just really like that. And I know I do that all the time because I'm trying to group stuff myself to understand how something is working. And it's also a low risk one because it's something you can do without, aside from what he mentioned, is you need to, of course, still run the tests, make sure there aren't side effects from doing that reordering. But beyond that, like it's all self-contained. You're not changing the names of anything. You're not changing the APIs of anything for the most part. So I don't know. I just really liked that one. It's nice and clean, and something that spoke to me as like, oh, I do this all the time.
I wrote that one down and I said, I rarely do this as a discrete, like individual refactoring. Like I rarely go into code and say, I'm just going to move this around and like make all the like things together. Like, you know, I'm playing that shape sorting game. I rarely do that, but I usually do it. Like it's usually the first thing I do when I'm trying to like refactor something, or I'm thinking about, hey, this doesn't make sense. Like, why is this happening? And I had an example this past week where I was it wasn't really a loop per se, but there was a big switch statement, and it was setting two different variables, and then one of them was like set at the top of a function, and then it goes to this switch statement, and only a couple of the cases affect it, and then at the bottom there's like some other stuff that works with that variable again, and then way down at the bottom of the function there's another thing uses it, and I was like, I can't like keep track of what this is doing or why it's doing it, so I basically took all of that, copied it, pasted it all at the top, and was like, okay, what is this whole chain doing? And then I figured out, oh, there's, you know, two special cases, and then you pluralize it in some instances. So I can make this all like one little 4 lines of code instead of needing to trace it through this long, there's probably like 30 lines, but you know, this long thing and not really understand what the heck's going on. So rarely do it like individually, but definitely always do it as part of a larger effort to understand or move stuff around. So I appreciated it too, Jeremy. And I know Bernard hated on it, but my favorite is the remove dead code. Like by far, I said worth the price of admission for the chapter, because like that's literally my favorite thing to do, is to send PRs that are just all red deletions, just like, yeah, we no longer need any of this. Like you no longer will come into this code base and need to read or think about why this is there, because it's not there anymore. It's gone. And then inevitably the revert because I broke something, because you know there was some test that did. Just kidding. That rarely happens.
Yeah, that one to me, I mean, was just obvious. It wasn't exciting, so I wasn't excited about it. It's definitely important. I mean, everyone loves deleting code they no longer need, but yeah, I mean, I think without the pipeline refactoring, I wasn't very excited about the chapter, because I feel like all of the things that he mentioned otherwise, like I've done before, I've experienced, I know, you know, I've done in some way, maybe without that same ordering or with the same name for sure. But that's what I meant with that one. It's like, oh, of course. I mean, of course, he's going to mention removing that code. That's an easy one. And you may not even need an example for that one. I liked how it actually showed the transition, that the first thing's like, you have some code. Look, now you have nothing. Wow.
Gray box with stuff inside. Gray box with nothing. You're welcome. Here's my contribution. Yeah. No, I mean, I think so. Like the first couple, like move function and move field, I think like as a mechanical operation, they were kind of, you know, okay, yeah, sure, everyone gets it. But I think some of the stuff that he said that I wrote down that was kind of interesting, or you know, I hadn't thought about it the way that he was presenting it, but he said something like the strength of a program is really like the foundation is the data structures. So like when your structures are done well, or like when you get the structures right, you have a lot less, well, he didn't say it like this, but like you end up with a lot less code, because a lot of times when you have poor data structure, you have a lot of code that has to deal with working that or massaging it so that it actually works for what you're trying to do. And so I thought it was interesting, because it, to me, you kind of summed it all up as, you know, the like you're going to learn a lot about what your data structure should be. Like you're never going to get it right the first time. It's something that should evolve, and like it's part of the problem domain that you're going to learn as you're working through it. And so like what's reasonable today and right today may be completely wrong next week. So like working that into the whole concept, I think of, you know, why we're talking about this book in the first place is, you know, good data structures without all that extra code make the intent of your application a lot easier to decipher. And so like that's kind of for me, that was the whole of that move field one, was around like how do you show the intent through data structure alone? Like not like we often talk a lot about like behavior, and like it's all, you know, what are the methods, what does it do? But that's really straightforward stuff usually when your data structures are right. So I think to me it was less like interesting in the mechanical sense, but more interesting in the what's the goal of moving fields around or even moving functions? Like, how do you make that, turn that into this data is in the right spot? So yeah.
I completely agree, and I highlighted that the passage where he's talking about as soon as he realizes the data structure isn't right, it's vital to change it. I think again, maybe it's changing code in general, but people seem to be very loath to do this. You know, I don't know, maybe it's just another symptom of not being willing or confident in changing code. And I think, Jeff, what you said is exactly right. You know, it was the right thing to do yesterday or an hour ago or 2 minutes ago, but as soon as it doesn't fit the current needs, then it needs to change.
Yep.
Yeah.
I think the best example that I can think of, so previous company, which, I mean, when I talk about it, you're going to know how I'm talking about, but when everything was first written, they had this concept of a resort. And so like resorts were, you know, hey, you're buying something to go to this one place, right? You're buying it just to go. So you're, you know, buying it to go to Park City or whatever, right? So one place. And so that was written into the data model, coded everything against a database tables called resorts. And then later it became that resorts actually had multiple types of these things. So instead of buying like a single pass to a resort, you might buy different types of passes. But instead of changing the model to represent that, someone just created a second thing and they called it a product group. And then, so what you ended up having is a whole bunch of code, and like people that joined the team had sticky notes that said like resort equals product, because that's how it is. So like if you wanted to talk about a product, you were talking about a resort, but if you were talking about a resort, you were talking about a product group in this code base. And so it's very complicated to, anytime you had like methods that people would come in and write, you know, they'd write product as a method name and then it'd be interacting with a resort. So you had to think about it every single time you encountered anything in the code base. And it was always like, well, can't we just change the name? And like that just word is like the worst thing, because you're like, well, I mean, yes, however, like if you change the name in the code, you also really need to change the database. So we have all these reports that are built around that. And so they all join like resort and product group. And so you'd have to like go through, and it was just like a, you know, probably a year-long project, like to just mitigate that particular problem. And so reading through that whole section, I was like, yeah, definitely seen this before as a, you know, you need to, as soon as you realize that what you named it or how you modeled or how you represented it or where you placed it is wrong, you should do the work then, or as, you know, quickly as you can, because otherwise you're going to end up with 10 years down the road, someone is putting a sticky note on their monitor just to remind them that a product is actually a resort, even though you work with resorts who are not products. And yeah, it's, there you go.
Yeah, I think even if those particular sections weren't the most exciting ones because you're used to them, I think they're maybe the most important, because especially for people who maybe, I think maybe like we're all sort of like experienced engineers, but it's like someone who might be reading this book for the first time might not have that context. And it's useful to know like this is kind of like a really like base level thing you should get comfortable being able to do, is you should feel confident to be able to rename something or being able to move something from one entity to another. And again, like driving home like the main crux of the book, which is like, can you do it with the test passing at every step of the way? Like if you can do that as an exercise and that is and you're consistent with that, then that's when I think you really truly like know the topic. I can't say that I'm to that point yet. And so for me, I felt like I got some value out of that, because just thinking about like what that whole process looks like.
Just, Jeremy, you just need to wait for my corollary book that says refactoring the test suite to make your refactorings work, right? So it's basically, you know, go and comment out the tests that are failing so that you
change your tests while you're doing the refactoring.
Yeah, you change the tests so that you're able to do your refactoring.
So that each step passes along the way, right?
Exactly.
Right.
Yeah, you got it.
You're saying it's refactoring all the way down, right?
Yeah, refactoring just top to bottom. Yeah.
It's interesting, Jeff, when you were talking about databases, and this is kind of an aside, but there's a companion, well, it's almost a companion book to this one. There's actually a book someone wrote called Refactoring Databases. And I think it's actually one of Modest Atlas' colleagues at ThoughtWorks. And I actually got it for Christmas. I haven't read it yet, but after we finish this, I may crack into that one, I think.
I wonder what that's like. I wonder if it's talking about like,
Yeah.
Like patterns for adding columns and moving data around, and should be a fun one.
Yeah, to me, it's kind of the combination of these refactorings, kind of these are little steps, but at the end, they become very powerful, right? I'm in the middle of doing something like that, saying I move a bunch of functions that are related from some helper method that the name doesn't make sense to, okay, these all relate to this data structure. And I know this is not a perfect class to have them, but now at least they are together. And looking inside those, for example, something that was very interesting to me is this decision of where to put the initialization of variables, of a local variable, right? Is to put them together, all of this, kind of make them kind of a group of initializations and then a group of using them, and his argument is very powerful, right? Not put them whenever they're going to be used. So you're doing this slide statements, and now you're together with this kind of separating the for loops. Now you have separate functions. So this big function becomes smaller and smaller functions, right?
Yep.
That's very nice. So I'm doing that together with this separation of these helper methods into, okay, these belong to this class. And eventually, I hope getting into this, okay, this belongs to a really specific data structure, right? It's kind of 2 or 3 steps further.
Mm-hmm.
One thing that I don't think he mentions, has mentioned here, is along these lines, we also have to deal with power. So we have code reviewers, and if the code reviewer is also a manager, no offense, Jeff or Bernard. So then become like, okay, his opinion seems to be more important than the other people's opinion, just because at the end they have the power. So it's kind of interesting also managing the dynamics, right?
The reverse is actually true. Your manager should have less say in your code. I'm just speaking as myself. Like a lot of times it's, yes, I have opinions or whatever, but it's like if I'm not there, like I would much prefer someone to, like, if I say, hey, this doesn't make sense, I would much prefer for them to explain to me why it does than for just say, oh, you're the manager, so I have to accept, your opinion. Like I would much rather you, like, it's part of a growing process, and like I'm, depending on the situation, obviously, but like typically the people who you're like deferring to in that respect are not in the weeds all the time, so they're not always there. So like they're not the ones that are looking at the code to be able to understand it. So like if you understand it better written the way that you wrote it, like it would make sense then to explain why, and then at that point you could reach like a mutual agreement as to what steps to take. So like just for that particular point, that his points about the localization or the location of initialization and that sort of stuff, I totally agree with what he's saying, and I think part of that goes back to what we were talking about earlier in terms of needing to understand and be able to see, like it's very hard to see what you could extract or what could be moved or what doesn't make sense where it is if you've got like an initializer up here and then you've got something that manipulates it here, then you've got some other thing down here. You'll never look at that as one discrete thing and say, oh, I can extract this into a method, or this actually is a thing that's operating on the on a subclass or operating on a collaborator or whatever. So putting them all together, like I'm totally in favor of that. And I think that pattern of what the old JavaScript like variable hoisting has done to everyone in terms of, oh, I have to declare my vars at the beginning of every function, and then so you end up with like, I can't stand whenever I see this equals null or this equals an empty string. And I'm like, why is it an empty string? Like, what is this? And it's, oh, because later down, they actually want to fill it in with its correct value, or it's going to go through this chain of obnoxiousness and get to its actual value. And I was like, I'd rather see that all in one place so I can see what's going on and know like who is responsible for setting it, who makes the decisions and what value it should have, or whether we should, you know, explode because we got certain values or whatever. So yeah, I'm on board with that. Like I'm on board with initializations as close as possible, and preferably not needing to initialize it to some temporary state that you then replace with like a function call. Like just fight against that as much as you can, because it's it just introduces cognitive load that you don't need.
Mhm.
I think to Antonio's point as well, and as you and Jeff have both said, is that idea of putting things that are related to each other next to each other. And I wonder if that's one of the more I think about it, well, I'm going to think about it right now, it seems to be one of the key takeaways of this book. You know, the split loop is about putting things together that operate together. And maybe the key thing you get in all of these cases is as soon as you do that, you begin to see other ways of structuring the code. Like you begin to see other, this can be a function or a method of its own. This can move into a new class. If I give this a name, it describes what it's doing. All that, you know, I wonder if that's almost like an unspoken rule throughout this book.
And another example I can think of is the shared parameters that go into different methods and like breaking them into an object. Well, we'll group those in an object because we always, they travel together all the time.
Mm-hmm.
Yeah. It's interesting. Yeah, the code review one is interesting as well. And I think, I don't know. It's a tough one. I mean, I always try and think of code reviews as being like, if I'm asking someone to review my code, I'm asking for feedback, but fundamentally the person requesting the review is in control, right? It's, you know, you're not asking for someone's permission. You shouldn't be asking for someone's permission. You're asking for feedback, but at the end of the day, you should be free to choose. But like, feedback should be, once someone said feedback is like a gift, it should be freely given. And if someone's insisting that you make a change, it's not feedback anymore. And this was in relation to feedback in terms of performance, right?
Mm-hmm.
But maybe it's the same thing in a code review, right? If you're insisting that someone has to make a change to bring it in line with the reviewer's views, then it's not really feedback anymore.
Totally.
Yeah, I mean, I can kind of see both sides, right? Like it's, you know, at some point when you're, so like the dynamic of, you know, someone is in charge. Like I disagree with the idea that, you know, someone's job is to defend your main branch or whatever, or like someone's job is to say, oh, I'm not going to allow that in here. Like I disagree with that as a, you know, I joke about that sometimes, but like I disagree with that as a, you know, thing. Like you're not trying to get a pull request past somebody, basically. It should be more of a, how do we share the knowledge of what's in this code base? And it's like when you're approaching code reviews as the person asking for the review, yeah, like it should be a, you know, I'm not asking for your, and the language is really weird in tools like GitHub because I'm not really asking for your approval. I'm asking, does this make sense? Like I'm asking, does like my approach make sense? Like, do we both understand it? Did I understand the problem correctly? And then do you understand it? Because ultimately we both have to, you know, maintain this code at some point. So like it's better if we're both looking at it. So it's kind of like the whole, you know, do you pair program or not? Or do you, like, are you code reviewing as a matter of, you know, process in terms of it has to be looked at? So like, you know, like PCI compliant stuff comes into mind. So like it's, are we checking for errors? And it shouldn't be like a game of, you know, who can make the, you know, best looking code or whatever. It's, do we understand this? Does this solve the problem to the point where, or like, did I think about this correctly? And so like the whole dynamic of, you know, whoever's approving code being the arbiter of, yes, I will allow this versus not. I don't think that that's the way it should be approached. I think what you're saying, Jeremy, is more, you know, hey, this works. Does this like track in your mind? And then it's more of a, it might make more sense if we do this, like I suggest these changes. And so like that's the language I prefer, but then, you know, GitHub is all over the place with, accept changes, and then it has request changes, and then you can approve them. And it's just like the language is really weird, but it shouldn't be that way. Like it shouldn't be thought of that way, in my opinion.
Yeah, I always treat code reviews as a good opportunity to like review the work that someone's done, to check for like obvious like issues. Like, oh, is this going to trigger a fatal error? I don't always succeed at that. I'm like, oh, this went out and we have a thing now where this doesn't work and now we need to put a patch out. But you want to kind of identify those areas. And then if you can, if it seems like there's something that could be improved through some sort of optimization, I like to like share things that I've learned or that I think I understand, or like what would help me read the code better 6 months from now. Or like if someone new comes onto this project and they haven't worked with this code before, are they going to understand what it means? We had a situation at work last week where we had a property that was getting assigned on an object, but there was no other reference to that property. And it's because we were like assigning it dynamically through like a JavaScript thing. And I'm like, well, I don't know what this is. I don't know what its type is. Like, so could we just get that property onto the class with some documentation? Like that would be enough for me to understand it later on. So when we come back, we know this comes from here and it gets assigned here. And I think like, yeah, I don't like the idea that like a code reviewer is a boss or someone that has to like, you must do this, but I think they're good learning opportunities for both the reviewer and the person who submitted the code. Because we kind of like you're basically coming to a consensus that we agree that we're going to be able to understand this when we both look at this down the line.
Yep. A lot of my comments on code reviews are like, hey, you could use this function or something, like something where it's like, oh, I see that you're doing this. There's a pipeline that does this, or you could improve this by changing this to make it either I don't want to say like less code, but like easier to understand, because it doesn't involve like 5 things. And like a good example of that is recently had something that was like there was a method that was being called, and then a temporary variable was getting assigned the result, and then there was a conditional, and then if you went and looked at the method that was being called, it had like a conditional at the first set that was taking a parameter from the caller. And so it was like this very convoluted thing. So if you ever wanted to understand it, it was only 10 lines of code, but in reality it was 2 conditionals and then a return value if those 2 were true, was the extent of those few lines of code. But it was like, I think you could clean this up a lot by just having a if this and then return, instead of like this temporary variable which is just assigned the name like return value or something, something weird like that. And it's like, it's more of the or if I looked at this, like you're saying, Jeremy, like if I looked at this in 6 months, would I understand what it was doing without having to go through this same process of tracing it? And if that's the point, then I would comment. But if it's like just a personal preference or hey, I've been reading this refactoring book and I think you should split this loop and do this and that because it's academically correct, like I think that's the wrong way to go about the process.
Yeah, I think the takeaway is that we're all going to go back to code reviews and we're all going to split loops every single, like that's going to be the recommendation for every PR going forward. Looks like you're doing 2 things in this loop. Can you do that loop more than once?
You have no idea. I'm going to actively look for that for like the next few weeks. I'm like, does this come up a lot? Like, I feel like it probably does, and I just gloss over it or whatever. But
I feel like I've done that so much in the past as well. So I mean, if that's anything to go by, then I'm sure it comes up a lot. And I can think of loops in the code I work in that are just ridiculously long. So, but I didn't write those ones. So.
The ones you wrote are not ridiculously long; they're just long.
Oh no, they're also they're very ridiculously long.
Oh, okay. Oh, they're worse. Okay, I got it. Nice. Anything else from the chapter stood out? No. It was a short chapter.
Mm-hmm.
I will say that. I did like the. I just turned to the page, so I'm looking. I did like the slide statement, like the example. Like there's this fragment of code that was like 13 lines, and it was just like const here, declaration here, let's move this down here. And I was like, see, this is like the problem that I have with coming up with good examples. And even when you jump into like the Code Kata land, they always feel super contrived. Like it's like, that's not, I would never, or I hope I would never like encounter that like in real life, just this, 15 lines of just straight up anarchy in terms of structure. But maybe that does exist somewhere. I'm sure it does. But so it's always, that's like those little ones always catch me, because it's like, slide statement, it seems so simple, and it's like, yeah, I probably do that a lot. Or extract function, I do that a lot. Or move function, I do that a lot. I just never thought to give it a name or even a second thought as to what I was doing or why. But like in the move function case, it's like, I think he talked about how like it's not really a light decision that you're making. It's actually, especially when you're talking about like object-oriented code, where you've got supers and subclasses, and you've got all kinds of stuff where you're talking about moving something, like you really need to understand the full context around it. I think that was what I took away from that particular refactoring, was it's all about what is the full context of what you're talking about. And like, you're going to get it wrong. Like that's part of this whole process, is like, it's a reflection of growing. It's a reflection of like understandability. And so like the process that he used for moving a function, like I think he had a nested function in JavaScript, then he pulled it to the top and he called it like top underscore, whatever it was called. And then like that very methodical, hey, I understand that there's probably some context that I'm going to miss. And I think he talked about like having two methods or something that were inside of it that he needed to move as well. And then should those go in the top, or should they stay as nested functions? Is that a good idea? And just like that whole thought process of, we do these things every day, most likely in our code, but there is like there's a very wide impact. It's like the whole idea that you need to have the test, I think, is kind of reinforced there. But it's just, I liked the approach that he took in terms of delegating and dealing with it that way. Like you're not just haphazardly adding a function to some module over here that does something and like copy pasting, or even cutting and pasting it and just redirecting everything. You do it like in a step-by-step, slow, methodical process. And like, I think that was my takeaway from like that particular section, was really think about what is the change you're making and what are the potential impacts, and like how much context you have to understand, and look at it that way, instead of just, hey, I'm moving this because I think it should move, or I'm moving this because I understand, like I have this limited view. Like really think about what are the actual larger impacts. So.
Yeah, I think that was present in move statements into function and move statements to callers too, because he had those like temporary function names in both cases. And it almost seemed like, because it's so methodical, it seemed excessive, but because if you go through the process and you learn the process, like it's not excessive. It's the whole reinforces that keeping the test passing through the whole process. Can I say process again? Or should I say it like process? I think maybe that's the thing too.
That's my accent. No, you're encroaching on the other Jeremy's accent now.
Nice.
Yeah,
All
he
right.
also highlighted the functions not having side effects is like really important, because he said, I think it was for the slide statement one. It's probably why he spent so much time like with the examples there, is like that's the only case you'll really trip up when moving these things, is if these things have side effects you're not aware, and then you have to dig into what it does, how it does it, and maybe functions that it calls as well. And it can, you can go down, rabbit hole there. So that to me is like, okay, yeah, make sure you don't have these side effects, use command query separation or some other means to kind of eliminate those as much as you can. If you can't, I mean, if you're using someone else's code, then you have to really do it carefully and not do even big slides, do them, little by little, because you may not know that you're, changing the behavior essentially, right?
Yep. All right, last chance.
Jeff,
go ahead.
You made an interesting comment a second ago about contrived examples. Maybe this is going to be slightly off topic, but I guess I have a kind of a theory about that, and also about why katas are valuable and why contrived examples are valuable. And I guess my theory goes, I mean, as you know, I come out of I used to be a professional musician, so I spent literally thousands of hours of my life practicing and or rehearsing and practicing. But we have the contrived examples in music all over the place. Like when I'm working on intonation or tone production or vibrato or any one of those other 1,000,001 technical things I have to be able to do, there's a massive value in having something contrived that lets me only focus on that one thing. I don't, when I'm playing or performing, there's 1,000,001 things I have to think about and get right at the same time. And the idea of isolating each of those is that the moment I need that technique, it's just instantly there for me. But I think you get the same thing in co-katas or in contrived examples in practicing these things, because you really focus in on that one thing. You get it to the point where you can execute it without even thinking about it. And then, you're practicing when it doesn't matter, so that when it does matter, you can just execute straight away. So I think for me, that's the big value of spending time doing things like katas, even if they are really, this code is so contrived it exhibits this one problem over and over again, but there's still great value in that. That's just my personal theory. I'm taking us way off topic with that.
No, it's fine. And I wasn't saying that katas are bad or anything. I was saying like in terms of when you're trying to apply this kind of stuff, it's like you're saying, like it's good to get the what they call muscle memory or whatever of the practice and getting through that process and like doing the sliding of the statements. But in the real world or in the performance of your piece, what you call it, practice versus rehearsal. So in rehearsal, even you may you don't have that isolation, and it's unlikely that you're going to end up with a very easy to digest for loop that has two statements in it, one of them being an if statement, so you can be like, oh, the pipeline is so easy to draw. Like that's great for the book, and it's great for the understanding what you're doing. But like my point was more to, it's easy to see it when the context you're looking at is really only that thing, or kind of set up to be only that thing, even though it's not how it would be in real life. So I think that was more my point, is it's just all of these things in isolation are they all like work together. So it's like as we go through these and we talk about like individual, like we talk about removing dead code, but that's actually a tale of it's the tale of the process of other refactorings that you did. So like they all kind of work together, I think was more of my point.
No, and my point wasn't to cast shade or to criticize what you said, because I think you have a very fair point. I'd be interested to discuss this again with you in a week or two's time, or with all of you, and to see like how you find, because I'm pretty convinced that if you practice these contrived examples, you begin to see how it applies in much more complicated code.
Mm-hmm.
I don't know. Go ahead, John.
No, I'm sorry. I don't mean to cut in. I think what you're both kind of saying though is kind of on the same path, which is that, how like when you learn a word or you just see a word and you're like, oh, that's interesting, and then suddenly you just see it everywhere. Yeah. Like that's kind of what this book is. It's like, oh, there's like these scenarios, and I want you to go look for them now. Absolutely. And now you're going to just be like in your code base and you're like, oh man, there's like a for loop right here and it's got two things and it could totally split it. I could do it there. Yeah, like you're just going to recognize, and it might be in part of like a bigger function somewhere. And you're like, within that, you're going to be like, man, we've got like these 5, 6 variables, like these can all go up here. We can separate them or reorganize them. Like you're going to start seeing all of that within like just very specific sections, but because you're practicing through this sort of like iterative approach and being like exposed to like these different types of approaches, that's when you'll see them in tandem. So you're doing your concert now and you're writing code and you're like actually doing the refactoring. You're like, oh, there's like 5 or 6 of these things now that I recognize right in this one place, but I need to do them one at a time also.
I think probably the best example of that is literally last week or the week before. I said I never inline functions. Like I can't think of a time I do it, and then I did it. I noticed that I did it twice in a week. So it's like the same kind of concept. Yeah. So
Mhm.
totally agree there. Yeah.
I agree, and I'm going to be seeing the word process everywhere from now on.
Process or process?
One of those, yes.
Nice. And then you're going to be sliding measures across and sliding keys up and down. No?
That's jazz, man. I'm a
Oh,
classically
jazz.
trained
Oh,
musician.
jazz. Yeah. Okay.
Yeah.
Gotcha. Sorry, my mistake. Yeah. That's a different refactoring. Okay. Yeah. Got it. Cool. All right. I think we're out of time. So we'll close this one down. Don't want to keep you all too late. So yeah, it was a good discussion. Next week we are talking about organizing data. So that should be good. I think this was a long one. I don't remember. But
A small chapter.
yeah, long chapter. Okay, cool.
No, that small chapter.
Oh, small
20
chapter. Oh, okay,
20
nice.
pages.
Nice. All right, cool. So you could do it on Sunday afternoon before we join the discussion, like Jeremy
Yes,
Ward.
it's 7
tends to
p.m.
do. Yeah, 7. Okay. Thank you all very much. Y'all have a good night, and I'll see you next week.
See you later.
Thank you.
Hi guys.
All right.